All right, so for slide 6, which quadrant do you think 560 degrees will be in? Make a prediction first and then press the button to check. So I know that I start here, and this is 0 degrees, and the first quarter rotation would be 90 degrees, 180, 270, and then 360. From here on, if we make another full rotation, 360 plus 90 would give us 450, and then 450 plus 90 would give us 540. So we're close to 560. From 540 to 560, we'd go another 20 degrees. And so I'm going to say that this is going to be in quadrant 1, 2, 3, quadrant 3 here. Okay. And then you guys can check that to see if it works. All right, so for question slide 7, for each of the 4 quadrants, give an example of an angle that is in each quadrant. So we have 1, 2, 3, 4 quadrants. And if I'm just doing one rotation around, right, you can do like 2 or 3 and get like 540 or higher than 360. I'm just going to make it easy on myself. And I know that in quadrant 1, it's between 0 and 90. So I'm going to say 45. 90 to 180 for quadrant 2. So I'm going to say 170 or 160 is what I typed. Quadrant 3 is between 180 and 270. So I'm going to say 200. And then between 270 and 360, I'm going to say 359. Okay. You guys can check yours to see if you have those in the correct quadrants. And moving on to the next question, when an angle is shown as a point on the unit circle, the x coordinate gives the cosine of that angle, and the y gives the sine of the angle. This is very important. This is what the unit circle helps you with, okay? So you could use a calculator and type in cosine parentheses 60 degrees, and you would get a decimal as your answer. You could do the same thing for sine. But what the unit circle does is it makes that all apparent for you on the unit circle. And what we see here is that our x coordinate is our cosine and our y coordinate is our sine. So instead of typing this on a calculator, you could just look at the unit circle, and that's what we're doing here. So the thing that's tricky about this is that our cosine comes first. I know you guys might be used to hearing sine, cosine, tangent. For this, we're going to go cosine, comma, sine. So our 0.5 is actually our cosine, and our sine is our 0.87. So based on this diagram, we know our cosine of 60 degrees here is 0.5, and our sine is 0.87. For slide 9, 2 angles are shown on the unit circle. State the following values based on the diagram. You can go back if you don't remember what sine and cosine are. Now, I want you guys to try to do this on your own, but I'm going to go over the answers for you. So pause it if you haven't done it yet, and then take a look at the answers as I do them on this video. So I'm going to look at 110 degrees first, and I know that my first coordinate is going to be my cosine. My second one here is my sine. So looking at this degree, 110, my cosine is negative 0.34 and my sine is 0.94. Now, my other angle measurement here, 25 degrees, negative 25 degrees, my cosine also comes first and my sine comes second. So my cosine is going to be 0.91 and my sine is 0.42. Now for this question, give an example of an angle which has a cosine value between 0.3 and 0.5. Use trial and error. So you can check your answers here, but here's a little tip. So I know that my cosine is my x coordinate, and it looks like my x coordinate is going to be positive. So I know that it's going to be somewhere here, right? It's going to be in my first or fourth quadrant because these have positive x values. Now, to take a guess here, I'm just going to type in different degree measurements and check. I know 30 degrees should give me a positive x coordinate, a cosine, which is true here, but it's not quite close enough. So keep playing around with this until you find something that's between 0.3 and 0.5, okay? And it should be less than 90 degrees to work.